All right, let's jump right in. Welcome to this explainer. Today, we're unpacking one of the most visually stunning and honestly kind of mysterious biological events on the planet. We're going to be looking at nature not just as, pretty scenery, but as a wildly complex system, one that operates with a level of precise design that is absolutely going to change how you look at your average garden. So let's set the scene. Picture South Africa, specifically Namaqualand. Now, for most of the year, this place is basically a barren wasteland. I mean, it's dry, it's dusty, and it's totally desolate. But then, almost like clockwork, late every August, it just transforms. It literally explodes into this breathtaking sea of flowers stretching out as far as the eye can see. It's a massive, stunning visual contrast. But the real fascination here isn't just that dry dirt suddenly burst into life. It's the absolute, flawless precision of exactly when it happens. And to show you what I mean, I want you to focus on a very specific number, 2.6. Dr. Jennifer Fitchett over at the University of the Witwatersrand analyzed an incredible 83-year record of these blooming patterns. We're talking data all the way from 1935 to 2018. And what her study revealed is staggering. These Namaqualand daisies are actually blooming exactly 2.6 days earlier every single decade, all due to climate shifts. They are literally tracking their changing environment with this microscopic, astonishing accuracy. Which, honestly, brings us to a massive puzzle. Do these plants keep a calendar? I mean, obviously not, right? But really think about it. How in the world could a plant, starting as a tiny seed buried deep in the dirt, possibly know exactly when it's time to bloom without looking at some 10-year record book or checking a local weather forecast? It forces us to ask this critical follow-up. How do they sense a shifting climate and then adjust their timing so perfectly? How do they know, hey, the world is getting fractionally warmer, and then shift their entire life cycle by exactly 2.6 days a decade? Well, to wrap our heads around this, we've got to zoom way out from the macro mystery of the desert and dive deep down into the microscience of biology. And this brilliantly highlights the hidden genius of seeds. Assistant Professor Shelley Lumba, she's an expert in plant biology at the University of Toronto, points out that seeds aren't just sleeping pebbles resting in the dirt. They're actually these tiny, incredibly complex data processors. Before they ever even think about sprouting, they have to integrate multiple environmental conditions to kickstart germination. They are, quite literally, running constant environmental calculations. Just think about the massive checklist of cues they're calculating all at once. We're talking light, day length, temperature, humidity, nutrient levels. The seeds have to measure all of these simultaneous factors, and they have to get it perfectly right. Because if they miscalculate and bloom just a week too early or a week too late, they could face conditions that are just too harsh, and they die. There is literally zero room for error out in the desert. So how do they actually pull that off? Let's get down to the molecular level. It all comes down to something called a phytochrome. According to researchers at Washington University in St. Louis, phytochromes are these special proteins inside the plant that act like highly advanced biological sensors. They don't just tell the plant if the sun's out. No, they detect the exact direction of the light, the intensity, the duration, whether it's early or late in the season. And amazingly, they even help gauge the temperature. They are constantly capturing a massive stream of complex, overlapping data every single second. Then, once all that data is crunched and the plant decides the conditions are absolutely perfect, it produces something really magical: phloragen. Think of phloragen as the ultimate switch. It is the specific, special molecule that finally gives the green light for blooming. It's the one signal that tells the plant, okay, the time is right, let's deploy the flowers. But here's the kicker. Producing phloragen is not a simple task. Research by Cornell University professor Robert Turgeon shows that over 30 different proteins have to coordinate flawlessly and precisely on time just to release this single phloragen molecule. Imagine a factory assembly line where 30 microscopic machines have to work in absolute perfect sync without a single glitch just to flip one switch. And guess what? The incredible complexity doesn't stop once the flower finally opens up. Professor Aaron Peshersky points out that a single flower scent requires up to 100 different chemical compounds, things like aldehydes and benzenoids, and they all have to be synthesized step by step just to attract the right pollinators. That is 100 different chemicals manufactured strictly on demand right inside a microscopic organic factory. Let's step back for a second and look at how this all comes together into what is undeniably a masterpiece of natural engineering. Step 1.
The plant meticulously measures the light and temperature using those advanced phytochrome sensors. Step 2, it perfectly coordinates 30 different proteins just to release that florigen switch. And step 3, it synthesizes a 100 chemical mixture just for its unique scent. The plant pulls off this staggering, sequential, flawless process every single year without fail right out of the bare dirt.
Now, this brings us to a really interesting philosophical pivot presented in our source material. Think for a second about a classic mechanical clock. It's got dozens of gears, all carefully engineered, timed perfectly, all working in unison so it chimes at the exact right second. We intuitively know that a precise clock requires a watchmaker, right? But compare that mechanical clock to a flower. The flower has advanced environmental sensors, a 30-protein internal coordination system, and a 100-chemical manufacturing factory, all working flawlessly together to bloom right on cue. So the source text raises a very logical and pretty profound question here. Did a flower, with its advanced light sensors and 100 chemical factories, just form by itself? When we're looking at a biological system that is so vastly more complex than the most precise mechanical clock we've ever built, is it really possible for such a flawless, intricate system to exist without an intelligent, precise design? To explore that, the source text shares a poetic and theological conclusion. It cites a quote from the Quran, Surah Ar-Rahman, verse 6, which says, "And the stars and trees prostrate." The text presents this verse as a beautiful, profound answer to the kind of awe-inspiring biological precision we've just been looking at in these plants.
What this means, as the source impartially explains it, is that the precise timing of the flower, measuring the light, understanding the changing seasons, and blooming exactly on time is seen as its universal harmony. In this framework, its flawless molecular mechanics aren't just seen as blind biology. They're viewed as a profound act of natural submission and design. The idea is that the plant doing exactly what it was designed to do flawlessly is quite literally its prostration to a higher order. So, I want to leave you with this final, provocative thought to chew on. If a single desert daisy requires such breathtaking precision, such a massive integration of complex systems and sensors, just to bloom for a few short weeks, what does that actually reveal about the complex design behind the rest of the natural world? The next time you see a flower bloom, don't just see a pop of color. Remember the invisible clockwork, the tiny data processors, and the majestic design operating right there, right before your eyes.